So we are going to start a section of this chapter that deals with what are called key features. And basically, we want to be able to look at a graph and make descriptions on that graph according to what direction it's traveling, what the sign is in that particular point, where it hits the x-axis or the y-axis, and then domain and range and end behavior. Lots of descriptions that are all based on the same picture. So we have here a story. The total profit of a lemonade stand by month is given by this function f of x. Create a table of values up to month 7 and graph the function. So how am I going to figure out how much the lemonade stand has profited at month 0? Plug 0 into the x. And 0 is actually really easy. What happens when you plug a 0 in there? Turns into 0. And right there, also 0. And then I get negative 2,000. So, uh-oh, I already killed it. Oh, this is not going to be a good day. Hang on. All right, let's try this again. Okay, so negative 2,000. How are we going to do 1? The exact same way. I'm just going to plug in 1, but I'm lazy. Are you guys lazy? Is there a faster way to fill out a table? Just graph it, and well, then I'll show you 2 different ways. So, going to go in my y equals and negative 500x squared plus 2500x minus 2000. And I'm going to just graph it in the standard window. Oh, that's really useful. What should I do? Oh, hang on. We'll get to that in a second. What can I do so I can actually see this graph? I could push zoom out. That's true. It would work. But a thing that might we might be able to see more of the shape of the graph is, let's set the table to match this window. So everybody push window, which is right next to y equals. What should I choose for my x minimum and my x maximum? Well, what are my x minimum and x maximum on the graph? From negative 2 to 7. And then what does scale mean? What does x scale asking us? Does anybody know what that is? The scale is the size of each mark. So how far apart do we want the marks to be? Well, look at the x-axis, 1. So I'm just going to leave it at 1. And then what should I choose for my y minimum? Negative 2,000. And my y maximum? So this is 12,000, but maybe we should go up to, what would the next one be? Or 1,200, sorry. 1,400, something like that. It doesn't really, I mean, you don't have to have it exactly the same, but I'm going to put 1,400. And what's my scale? How far is each mark on the y-axis? 200. Or you could do 400. It doesn't, it doesn't really matter, but we wouldn't want to say like 10. If we chose 10, there would be so many marks we wouldn't be able to tell the difference. It would actually just look like a solid line. And we wouldn't want to say 1,000. So 200 would work, 100 would probably work, 400 would work. I'm going to put 200. And then this other space right here, X resolution, That just wants to know how fast do you want to graph it. Because sometimes equations are so complicated that when you push graph, it takes a really long time for the calculator to compute the points. And so when that happens, you want to speed up the graph. You want to choose 2 or 3 or 4. You can only go maybe to 5 or something. But the trouble is, the faster you graph, the less accurate it looks. So if you have a really simple graph, like this, some kind of x to the third graph, and you ask it to graph at speed 5, well, if you did speed 3, it might look like this. If you did speed 5, it might look like that. So in this class, we're never going to graph anything complicated enough to speed up the resolution. So just always leave it at 1. There's really no reason to have it set at anything other than 1. Because every time you speed it up, you do lose some accuracy. Unless the graph is really complicated, then it will look normal, but we won't ever be doing that. Okay, so push graph. That looks much better. Okay, and I want to know, where is the graph at 1? Well, we can ask the calculator, what is the value at 1? And the way you do that is you push trace, and then you can move the arrow, the little cursor around. The only trouble is the cursor is never totally accurate. You can never actually hit the number you want. But if you push trace, you can type in numbers and get the answers. So if I want to do 1, I just push 1, and I get 1 comma 0. And then if I want to know what the answer for 2 is, once you've already pushed trace once, you don't need to push it again. So I can just type in 2. So 2 comma 1000. Okay, I'm getting lazy again. This is too hard. Too much work. Bryn, what do we do? Second graph. So second graph gives me a table, and all the numbers I want are right there. Okay, now you can actually set your table to anything you want. So if you look above window, you see table set. Push second table set, and it will ask you 2 questions. Where do you want the table to start? And we want it to start at 0. You could pick -8 or 12 or 27, whatever you want. And then that little triangle table, that little triangle is the Greek symbol delta. And in mathematics and science, the symbol delta means change. So delta table is asking, what do you want the step, the change on each level of the table to be? Basically, what do you want to count by? Do you want to count by ones? Do you want to count by fives? Do you want to count by a quarter? Or do you want to count by pi? Something like that. So you can set the table, the delta table, to anything you want. Now, we usually just leave it at 1. Okay. And then independent and dependent, don't worry about those. Those are really not important. And incidentally, when you go back to window, you see delta x down here. And that wants to know that these calculators can't really graph lines because there are an infinite number of points in a line. So what it does is it just draws a whole bunch of dots. And it puts the dots so close together that you can't tell that they're separate. And so delta x is just asking, how far apart do you want the dots to be? And sometimes when you draw a really steep graph, so if you draw a graph that gets really steep, when it starts to get steep, it starts turning into dots. Because the spacing between the dots is so large, and the graph is so steep that it actually splits it up. So you could change your delta x to something smaller, and then it would look more like a line. Or if you like dotted graphs, you could make your delta x really big, and then it will graph a parabola in dots. And then the same thing with the trace steps. When you push trace and you're moving the cursor, how far do you want it to move each time you push the arrow? And you can change those, but there's there's really no reason to mess with delta x and trace steps. Okay, so we need to copy copy those numbers down to our table and draw the graph. So go ahead and do that. Oops. Oh my gosh. I died again. It's frustrating. Okay. So that's the shape of our parabola. Now we have a bunch of questions that are going to ask about what's happening in the company. Now, this particular curve is the profit curve. And X is in time, which is in months, and then the Y value is in dollars. So any point out there tells you how far into the company we are and how much money the company has made overall. It's not how much they made in a particular month, it's how much they have made up to that point. Okay, so um, the first question asks, how much did it cost to start the business? Where are we going to find that information? So month 0, negative $2,000. Why on earth would a lemonade stand cost that much? Expensive lemons. I don't know. Maybe they had to build the stand, so they bought a whole bunch of lumber and built the stand. Okay. And you can see that if this is time going in this direction, then y equals 0 is right now. And we go down, and at y equals 0, or sorry, at x equals 0, the y value is negative 2,000. When did the company break even? Where are we going to look to find where the company broke even? Where the graph hits the x-axis. So we have break even at month 1 and at month 4. What does that mean? How can we break even twice? Does that make any sense? No? Well, it certainly makes sense the first time. Okay, and if you think about this as the value in the checking account, or the value of the checking account for this company. So you go out and you take a $20 or $2,000 loan from the bank and you start a lemonade stand. Then you start making money. And every time you make money, you put it in the bank. And at month 1, the amount of money in the bank is $0, which means you have paid for that initial $2,000 loan. Okay, you've broken even. You have spent just as much money as you have brought in. And then it looks nice as we go above the x-axis and we start having more and more money in our bank account. But at some point, the value of the bank account starts to go down, and eventually it goes back to $0. And then after that, it just kind of sinks into oblivion. Okay, So when did the business break even? Month 1 and month 4. Okay. When is the business profitable? Above the x-axis. What about on the x-axis? Is it is it profitable when the graph is on the x-axis? What does profitable mean? You've made money. If you have $0 in the bank, have you made money? No. So we would have to say it's above the x-axis, not on the x-axis or above. We have to say above. Okay? And what are the particular values? So when is the business profitable? Okay, here month 2 and month 3, there's a little bit more than that. Between 1 and 4. And do you guys know how to do interval notation? So we're going to say 1 comma 4. And if 1 counts, then we put a bracket around it. If it doesn't count, we put a parenthesis around it. Do you guys remember this? So does 1 count? Is it at exactly month 1, is it profitable? No. What about 4? Nope. 4 is on the line. They're both on the line. So a really quick review on interval notation. How do I write that interval using interval notation? Well, it would be 2 comma 3 bracket parenthesis. Does that make sense? The left side counts. 2 is part of the answer, but the right side does not. Okay. What about this? What's the interval notation for that? Well, you always start on the left. What is the left side of this interval? Negative infinity. Good. And what's the right side of the interval? Negative 2. Does negative 2 count? Yes, because it's filled in. It's equal to. Does infinity count? Can you ever actually grab infinity? Well, not in this class. When you get to calculus, you'll start doing that. Calculus is the mathematics that allows you to tame infinity. You can actually do infinity math. It's really fun. Infinity plus 1? It's infinity. What about infinity minus 1? Still infinity. Infinity times 3? Infinity. Infinity divided by 1,000,000? Still infinity. Yeah. Infinity math's really difficult. The problem is when you start doing stuff like this, infinity divided by infinity, that's kind of hard. Or infinity times 0, that gets a little complicated. Also, infinity minus infinity, that's a little bit harder to do. But you can still do it. We have some tricks that let you do that. Okay. When is the business not profitable? So it would be anytime it's below the x-axis. What are the particular intervals for that? Well, we got to do the left side first. So we're looking at this piece. What is the interval set for that piece? What's the left side of that? 0. We can't do negative infinity because we started the business at month 0. So even though the graph kind of goes out to infinity, the business doesn't. So we're going to say 0 to 1. Is 0 part of that interval? Is x equals 0, sorry, does x equal 0 give us a y value that is below the x-axis? Yes, so that one gets a bracket. What about 1? Does x equals 1 give us a y value that is below the x-axis? No, it is on the x-axis, so 1 gets a parenthesis. Okay, and let me show you why that's the case. So we look here. Is this point below the x-axis? Yes. So that is included in the not profitable interval. And all of these are below, 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 below until I get right there. That number is not below the x-axis. It's on the x-axis. So are we in debt when we hit the end of month 1? No. We have broken even. Okay? But that's not the only piece. There's another piece right here. When does that piece start? After 4. So I need to do the first interval, and then I use this little symbol. It's a U, and that's called union, which means we have 2 different intervals, and we're combining them together. So union with 4 to, when does this company end? In infinity or 7, and that's, it didn't really tell us. So if you put 7 or infinity, I'm not really going to care, because technically the graph goes forever, but we were never told when the company stopped. And really, are you going to keep the company open with numbers like this? No, at some point you're going to close it. So I don't know, I'll put 7. Does 4 create a y value that's below the x-axis? No. So it gets parenthesis. Does x equals 7 create a y value that is below the x-axis? Yes. So that one gets a bracket. Okay. When is the stand making money? So we just talked about when the stand is profitable, which means you look in the bank account and the number in the bank account is positive. Okay, that's a different question than asking, good catch. That's a different question than asking, when is the company making money? So how do we know when the company is making money? Say it louder. When the graph is going up. But wait a minute. What does up mean? Well, if you follow the line this way, that's up. But if you follow the line this way, that's down. So when we say up, what do we mean? Up to the right. And why do we do up to the right? Because time always moves to the right. And we call this part of the graph increasing. When is a graph increasing? When it is going up to the right. So can you pick a section of the graph that is going up to the right? And the answer is, it's this piece right here. Okay? Which x values make the graph go up? Well, what is the x value on the left? What's the furthest most x value for that piece that I just circled? 0. So 0 to, when does it stop going up? Oh, yeah, it's not on our table, is it? So you're saying 2.5. How do you know that? So you can look at these points right here, which are these 2 points, 2, 1000 and 3, 1000. The maximum has to be right in the middle of both of those because parabolas are symmetric. And usually we won't have those numbers. So what you might want to do is look at those two, the 2 roots. What number is halfway between x equals 1 and x equals 4? And the answer is just find the average. 4 plus 1 is 5 divided by 2 is 2.5. Okay? So this graph is going up from x equals 0 to x equals 2.5. Is the graph going up when x equals 0? So here's what I like to think of that of. If we're in a little car and we're driving up this hill, if the car is at x equals 0, is the car tilted toward the sky? Yes. So 0 gets a bracket. Now we're going to drive the car. We drive the car up the hill. When we get to the top of the hill, we're sitting at x equals 2.5, which is right there. Is the car pointed toward the sky? No. Is it pointed toward the ground? No. It's flat. So at x equals 2.5, is the graph increasing? No. It's not decreasing either. It's actually totally flat. There is one instant right at 2.5 months where the graph is flat. So 2.5 gets a parenthesis. Now, one of the biggest mistakes that people make on the test when they're doing increasing and decreasing is to label the y values. So notice, when we talked about this question, we did not mention how much money the company had at all. We didn't reference the y values at all. We only dealt with the x values. And that's true of positive and negative and increasing and decreasing. So we don't ask how much money is there when the graph is going up or anything like that. We simply say, when is the graph positive? When is the graph negative? When is the graph decreasing? And the answer to every when question is tied to time, and the x-axis is time. So I didn't say the graph is increasing from negative $2,000 up to whatever that is, 1,100, or we'll find out what that is in a minute. I asked, when is it increasing from month 0 to month 2.5? Okay, and I think you guys will learn this stuff just fine, but for some reason on the test, a lot of kids forget to label the x-axis instead of the y, or sorry, they label the y when they should label the x. Okay, when is the graph decreasing? Well, this chunk is decreasing, so the left bound is 2.5, and then the right bound in this case is a little tough. It could be, what are my choices? 7 or x-axis, right? So a lot of people look at this and say, oh, it's going down. Well, 2.5 to negative infinity. But you can't have a positive number on the left and a negative number on the right. It's not built that way. So we have to label this in terms of the x-axis, which is going to the right, which would be infinity. So parenthesis, parenthesis. If I put 7, would it be a bracket or a parenthesis on the right? It would be a bracket, because 7 is going down. If you're driving a car and you're at x equals 7, you're certainly aimed down. All right. Next question. How can you explain the shape of the profit curve? Why might a lemonade stand, let me get rid of some of this garbage. Why might a lemonade stand profit curve look something like this? So why did we start $2,000 in the hole? Okay, we had to pay for the business. Okay, that makes sense. Then what happens? Made a whole bunch of money. Why? Because people wanted your lemonade. Then what happened? People stopped wanting the lemonade, and for some reason you just kept making it. You kept buying those lemons, and you're just taking the business down into the hole. Okay? Why might a lemonade stand do that? Seasonal. Right? You open the lemonade stand at the beginning of the summer. For the first couple months, you make a lot of money. Then it starts getting colder, and people don't want lemonade anymore, and you keep making it and buying lemons, and you end up in the hole. Okay? There are lots of other explanations. For instance, My favorite might be that at month 2.5, the world population of humans is totally eradicated, except you, and the aliens inhabit the earth, and they don't like lemonade, but you keep making it for them. So I don't know. Lots of reasons why it might look that way. Well, so that's a good question. So here we have made money. If I keep buying lemons, I'll still have a positive amount in my bank account for a while, right? Because I've made that much money. But if people stop buying my lemonade and I keep buying supplies, then I'm going to start losing money. Or maybe they slow down, they don't buy as much. So there are a lot of explanations. Okay. Um so describe what will happen if the business stays open forever. Good. Depending on why we went up and down, it might oscillate. It might turn around, come back in the summer. That's true. But for this particular equation, apparently it's going into the negatives forever, which explains my alien idea, I guess. Doesn't come back up. So, and what that question is asking is, where is the right side of this graph heading? And the right side of the graph is heading into the abyss. It's just going off into nowhere. Okay. If the stand was open for 5 months, so we are going to throw out these two values. If the stand is open for 5 months, oops, what is the domain and what is the range? Okay, so we're going to stop the graph right here. What is the domain of that section of the graph? What's the furthest left x value? 0. So we're looking at the x-axis. And when we look at the x-axis, we take this line and we run it around and we see when it hits and when it doesn't. Are there any places where this line does not hit the graph? Yeah, it doesn't hit over here. There's nothing over here. And then there's also nothing over here because I stopped at 5. So the domain is going to be 0 to 5. What symbol does 0 get? Well, does 0 count? Which in this case means, does that vertical line hit the graph at x equals 0? Is the lemonade stand open at x equals 0? Yes. So that gets a bracket. So oh, that's not what I wanted to do. So I do hit the graph there, and I continue to hit. At 5, do I hit? Yes. Do I hit at 5.1? No. It stops at 5. So the right side of the domain gets a bracket. All right, now for the range. For the range, I need to draw a horizontal line. And I'm going to move this around. Does that line ever miss? Yeah, it misses up here. And it actually also misses down here because we stopped at 0 and 5. And for some reason, people get the range backwards a lot. I'm not really sure why. But remember, you always start with your small number, comma, big number. So on this graph, what is the smallest y value? It's going to be right here at negative 2,000. So negative 2,000. And when does it stop hitting? I don't really know. It's somewhere up there. Yes? So how did you get 1125? Okay, good. So first off, do I know the x value of the maximum? So this point right here is something, comma, something. Do I know the x value? Yes, it's 2.5. How did I find that? It's halfway between x equals 1 and x equals 4. 1 plus 4 is 5. 5 divided by 2 is 2.5. So I could just go to my graph and push trace and type in 2.5. And I get 1125. So this would be 1125. Does the graph exist at y equals negative 2000? Does the line actually hit at negative 2000? Yes. So this gets a, if negative 2000 counts, it gets a bracket. Does 1125 count? Yes, so it gets a bracket. Now, what if I don't know the x value for the maximum? Well, there is a way to ask your calculator what the maximum is. So right above trace, you see the word calc. Everybody push second calc. And then number 1 just finds any y value given an x value, which is what you get when you push the trace button. 0 will find the roots, where the graph hits the x-axis. Numbers 3 and 4 will tell you where the minimum is or the maximum is. In this case, we want to know maximum, so I'm going to push 4. And I need to point, I need to pick some number to the left of the maximum. So it says left bound, so I'm going to move my cursor over to the left. And then when it doesn't really matter how far to the left you go, as long as you don't go so far that you capture another maximum. And the cursor is really slow, so I'm just going to type a number in. I'm going to say 3.5. Is my maximum between those two arrows? Yes, and it asks me to guess. I think it's 2.6542. And it says the answer is 2.50000221125. Now, do you see that extra 22 at the end of the x value? That's a calculator pretending that it's more accurate than it actually is, and it made a mistake. Anytime you see that, that is a calculator error. So if you see 4.9999997, it means 5. Okay? It doesn't mean it's close to 5. It means it's exactly 5. The calculator just makes mistakes. And the closer, the narrower your arrows are, your left bound and your right bound, and the more accurate you are on choosing your maximum, the less often that will happen. Okay, so that gives me my 1125 right there. Okay, interpret the domain and range in terms of the business. What does this mean in the story? What's that? So it means that the lemonade stand was open for 5 months. Yep. Okay. What does the range mean in terms of the story? The most the company was ever worth was $1,125. I guess the most cash the company ever had was $1,125, and the least amount of cash they ever had was negative $2,000. All right.